I welcome you all for this presentation. In this presentation, we are going to discuss about implementation of stack operations. This is the overview of this presentation. Introduction to various operations of stack, then the functions of stack, then array implementation of stack. There we are going to discuss about how to declare the array variables, then how to create a stack, then how to push an element into stack, then how to pop an element from the stack, then checking for stack empty and checking for stack full, followed by example for stack using array. This stack empty is to check whether there is underflow or not, and stack full is to check whether there is overflow or not. Other operations you are very much familiar. Let us see how to implement all the operations. So we all know that these are the main two operations in stack data structure, push and pop. Push is to insert an element in the stack and pop is to delete an element from the stack. And here these push and pop operations all are performed on a position called top of the stack. It is also called as peak of the stack. So what is the difference between this stack data structure and array? Here we are using the array implementation of stack, but there is one main difference between the stack and array. Here all the insertions and deletions we are performing in one position, that is top of the stack. But in array, based on the index of the array, we can perform all the operations in any of the position. It is not necessarily that in top alone we are performing this insertion and deletion. So only this stack data structure is called as last in first row. Whichever enter last will be coming out first. Other than this push and pop operation, we need to create a stack. Then we have to check whether the stack is empty or not. That is whether the underflow condition exists or not, that we have to check. So we have to we are having this function also, this operation. Then is full, that is we are checking that overflow or not. Where we are using this underflow and overflow means if we are popping off an empty stack, then this situation arises. So why we have to spend one operation? So in order to reduce that, we are just checking. If you are performing pop means we are first checking that whether the stack is empty or not. If it is empty, we are not performing pop operation. If it is not empty, then only we are performing pop operation. Likewise, similarly, if you are pushing into the stack, if there is any space in the stack, then only we can push an element in the stack. So that why we have to waste one operation for that. In order to overcome that, we are first checking whether overflow or not, stack is full or not, we are checking. If it is not full, then only we are pushing an element in the stack. If it is full, we are not pushing an element in this stack. A push not possible. Likewise, we have to display some message. So these are the 5 operations or 5 functions we are going to discuss in this presentation. So in the function format here, it is all the functions are written. We are having push function, pop function, create function, is empty function and is full function. So this push function we are having, push means we have to insert one element in the stack. So in order to insert an element, we have to pass the element along with this function. Before that, we are having one stack data type. It is a pointer variable. Star means we can easily know that it is a pointer variable. So here this push function is to insert an element in this stack. Then pop means we have to remove and return the top element in this stack. Create is to create a new stack. And is empty is to check if stack is empty. Is full means check if the stack is full. Let us see all the functions in detail. So in this array implementation of stack, these 3 things we have to do, 2 things mainly. So declare an array of fixed size, that is it is array implementation. So if I am telling that array implementation, what is the other implementation? Obviously this question may arise. So another implementation is linked list implementation. So after discussing array, we already know you have studied in programming in C. That's so we are not discussing about arrays and directly we are start the implementation. But linked list, it is new for you. So after discussing linked list, after the completion of queues, array implementation of queues, we will discuss this linked list. After discussing linked list, we can start implementing using linked list also, both the stack as well as queue data structure. So now we are only discussing about array implementation. So in the array implementation, we have to declare an array of fixed size, and this array determines the maximum size of the stack. And another thing is we have to keep a variable which always point to the top of the stack. Here we know that top plays a vital role in stack. So we have to keep a variable which always points to the top of the stack. And it contains the array index of the top element. We have to have the array index of top element, because from with that only we are performing a push and pass in pop insertion and deletion operation we are performing. So we must have the array index of the top element also. So this is the declaration. Here we are defining a macro, that is hash define max size 100. That is whenever if you want to increase the size of the array, at that time here itself we can change it. So wherever in the program max size arises, no need to change there. Automatically if you change here, it is replaced. Once we are executing the program, it is replaced. So no need. So only here we are defining the macro for simplicity. Hash define max size is 100. This is the maximum size of the array as well as the size of the stack. Then here we need to define declare one structure of the stack. Here it is struct. It is a keyword for structure. We are using the struct keyword. We all know that structure consists of different data types. So then this one is the structure name. So structure name may be anything. Your name also you can give, no issue in that. But this struct is a keyword. You can't change it. Then here we are having two items in the structure. That is two data types or two items are there. One is st of max size, that is array of size 100. st of 100 meaning that it is while executing it is replaced like st of 100. Generally we used to declare array as a of 10 likewise, or a of 100. Just like that here for the stack size it is given as st of max size. Then another variable we want to keep is the top. So it is an integer type. Top is an integer type. So here these two forms a structure called last in first out LIFO. Then we are defining the type of this LIFO as a stack. Redefining, that is type definition. Struct, it is a keyword. This type def is also a keyword. Then this LIFO is replaced with stack. Then we can, wherever we want to use LIFO structure, we can use stack. Stack is here. This stack is also declared here. Here meaning is S is of type stack. Stack is a structured data structure. It contains two items. Next is stack creation. It is very simple. We are just creating an empty stack. Here one thing you have to keep in mind is we know that top plays a vital role. So if we are creating an empty stack, say for example now we are going to create a stack of size 100, right? So always we are having 0, 1, then 2 up to 99. So this is our stack size. st of 100 is we are having 0, 1, 2 up to 99. So how to create an empty stack? Because for pushing any element in an stack, we need to increment the top, then only we have to perform insertion. So if I want to insert the first element, I have to insert in the 0th position only. So what is our working model? We have to increment the top, then only we have to place the element in that position. So if I am going to insert the first element in the stack, the top is incremented, and after incrementation the top equal to 0. Top equal to 0. So in this top equal to 0 only I am going to push some element. So if I want to create an empty stack, at that time what is the position of top? The previous number from 0. So top equal to -1. So here while creating a stack, what we are doing is void create. We know it does not return any value. So void create stack. Stack is a structure. We know that star s. It is a pointer variable. So how we have to use this pointer? S points to top equal to -1. For initializing this stack pointer value, we have to give yes, it is a stack. Point to what value? It is a top equal to -1. So S point to point points to the last element pushed in. Initially, it is -1. Always top points to the last element that is pushed in. Because we are incrementing the top, then we are inserting. So it is in that last pushed position, it is there. Initially, always it is -1, because once we are pushing an element in this stack, first element, the top becomes 0. So -0 minus 1 is -1. So only initially it is -1. Next is pushing an element into a stack. I already told you that if we want to insert any element in this stack, that is we want to push an element in this stack, we have to increment the top position, then only we have to insert the element. And in the declaration part itself, we have seen that we are having two parameters, that is not in the declaration part. While discussing about the stack functions, there itself we have seen that push consists of two parameters, that is stack S and element of type integer. Whatever the element we are going to insert, that we have to insert it. So if S points to, then here what, if you want to perform push, what we need to check? Whether there is any space in the stack to insert this element or not, we have to look into. So we have to check for the overflow condition. So what is my overflow? Here we are having 0 to 99. Overflow means if all the 100 elements are filled, then only overflow. So what we are telling is, if S points to top equal to max size -1. Here what is max size -1? It is 100 minus 1, that is 99. That is all the 100 the free spaces are filled. Then we are telling that if this condition is true, that is if S points to top equal to max -1, this condition is true, then we are telling that stack overflow. Else we are incrementing the top position, and in the top position we are placing the element. So S points to top plus plus, S points to stack of S points to top equal to element. That position we are inserting the element. This is about pushing an element in the stack. Next is pop an element from the stack. If you want to pop an element from the stack, just you have to decrement the top position. That's it. And one more thing, we have to check whether the stack consists of elements or not. So we have to check that whether the stack is empty or not, we have to check it. So if S points to top equal to -1, because initially if there is no any item in the stack and only the stack is there without any elements, then only the top position is -1. We know that. So S points to top equal to -1, then we are printing stack underflow. If this condition is not true, we are just returning S points to ST of S points to top minus, just decrementing the top position. Next is checking for stack empty. In the is empty of stack is, already we have checked is empty. It is a underflow condition. So same thing only we have to write. If S points to top equal to -1, return 1, else return 0. Then for the stack full, it is a overflow condition. So S points to top equal to max -1, you have to return 1, else return 0. This is for stack full condition, overflow condition. And a stack empty means it is a underflow condition. So this is an example of stack using array. So whatever the functions we have discussed, all those things you can have in this program, and you can create a new C program. This is your second exercise, implementation of stack using array. So here we have to include the header file. This is about C programming. If you want to use C++, you have to change accordingly. Hash define max 100. This structure we already know. Type def also know. Here void main of. Then we are calling, we are initializing, declaring the stack variable C and B. Two stacks we have created. So create stack, create of ampersand A, create of ampersand B. Two stacks we have created. Then we are performing push operations. Finally, we are performing pop and printing those values. Then we are checking that if stack is empty or not. B stack is empty or not. We are just checking. That's it. So in this presentation, we discussed about introduction about the stack operations. Then we discussed about the 5 stack functions, that is stack creation, then push, pop, is empty, and is full. Then we have seen about the array implementation of stack, starting from the declaration, then stack creation, then pushing an element into stack, then popping an element from stack, checking for stack empty, checking for stack full, and we have seen the example for this array implementation. Thank you.